everyone, in this video we're going to look at grouped frequency tables and histograms, and we're also going to look at segmented bar charts as well in some of the questions. So a frequency table can be used for all types of data. You can have it for categorical data or numerical data, but the frequency is just how often it occurs. So with a grouped frequency table, often we would group data when we've got a lot of it. So if I just highlight here that we've got 292 bits of data. So here we're looking at, I don't know if we've got a context, the following grouped frequency table and histogram both show the times in minutes taken by 292 participants to complete a half marathon. All right, so that's what data we're looking at. So 292 people completed a half marathon. So basically down this end, they're fast, and then I'm down here somewhere slow. All right, so that doesn't matter though. We're only looking at the histogram and the frequency table, but if you're thinking of it in terms of the context, we're running a half marathon here. All right, so we don't need all that business. Okay, so what we need to remember is we group it when we've got a lot of data. All right, drawing a dot plot for this would be ridiculous. All right, we'd have 292 dots. All right, takes way too long. With your interval here, so 60, what this means is 60 to 90. So if you ran between 60 and 90 minutes, you would go here. And it would be continuous data, so continuous numerical because it's measured in time. So if you ran, say, 89.9 minutes, you would be in this orange section, but if you ran 90 exactly, you would be in the blue section. So that's basically all it means. So we have a bar for each interval. So from 60 to 90, we can see on here, we can go across just under 15, in which we can see a bit better on the frequency table. Then from 90 to 120, we can go across just under 50. There it is at 48 on our frequency table, and so on. All right, so if you were to interpret a histogram, your scale would be a little bit easier to read. So for this one, we've got the frequency table, so we don't really need to read off the axes. Your axis doesn't have to start on 0, so we can see here it starts at 30. That's only because you don't want a huge gap between 0 and your starting value, which is 60. You can do that. You might also see that little squiggly line there to show that it doesn't have to start at 0. All right. Looking at the center and spread of histograms. So here we've got 2 histograms. If you kind of don't really take much notice of the axes, like squinting your eye, they look exactly the same. All right, they're the same kind of shape. That just means that their spread is the same. All right, so remember, spread is your highest minus your lowest. So here the highest is 60, the lowest is 0, so your range is 60. Here our highest is 90, the lowest is 30, so the range is also 60. So they have the same spread, but they have different centers. So this isn't, well, it's kind of symmetrical. You can say the center is probably going to be between 20 and 30, whereas this one would be between 50 and 60. So same spread, but different center. It's just moved along a little bit. And then we've got, I was just reading the question, so we've got 2 distributions with the same centers, but different spreads. So we can see here the center is between 50 and 60. Here it is also between 50 and 60. But the first one is more spread out. The highest is at 110, lowest is 0. So it's a range of 110. The highest here is 90 and 30, which is 60. And I'm assuming that the highest is 110, the lowest is 0. It might not be, but that's okay. For the discussion here, we don't really need to know exactly what the highest and the lowest is. All right, so with your shape of your histograms, as I alluded to in a previous video, you can have symmetrical. All right, so it's going to be approximately symmetric. It can be positively skewed and it can be negatively skewed. You cannot have symmetrically skewed. All right, that's an oxymoron. They're the opposite. It's like I'm skinny fat. All right, they're the opposite. You can't be both. You're either one or the other, or it's hot cold, or it's quiet loud. You know, they're two opposites. All right, it's one when you're doing the shape of a histogram, or it's called the shape of the distribution. It's one of those three. All right, so good thing about general is you just got to get used to using your notes. So we've got approximately symmetric, or you've got positively skewed, or you've got negatively skewed. Now, just looking at these two, so the first one we've got symmetrical. Here is a double peach symmetrical. I've never really seen one like that in general, but there it is if you need to refer to it. And then we've got the skewed distribution. So positively skewed just means your tail is skewed in the positive direction, and negatively skewed, it's skewed in the negative direction. So these should definitely be in your bound reference, so you can refer to them when it asks you for the shape of the distribution, which it often does. So either for a histogram, or it could be for a box plot. So when we get to box plots, you'll see that. Now for outliers, an outlier, remember, is an extreme value. All right, so in the previous video, we were looking at the amount spent at a shop. So they were all like $1 or $2, and then there was a $16.55. That was an outlier. With histograms, you can't calculate if it is an outlier, finding the lower fence and the upper fence, which we'll do when we look at box plots. You just got to see that it's an extreme value. All right, so it's a possible outlier when it's not with the pack. All right, so when it's out of the pack, it's probably going to be an outlier or a possible outlier. All right, so we kind of went through this in the previous video. We don't really need to do it again, but because we touched on skewed distributions, so just remember, when it's symmetrical, we can use the mean or the median, but when it's skewed, or if it's got outliers, we do use the median. All right, so let's move on to some questions. All right, so here we've got, we're looking first of all at frequency table. So the table shows the frequency distribution of school type for a number of schools. Write down the information missing from the table. All right, so we've got school type, Catholic, government, and independent, the number, and then we could also calculate the percentage. So the percentage is just the number, which is 11, over the total, which we haven't calculated yet, so let's quickly do that. It's 20. Oops. Times 100 to convert it into a percentage. So 11 over 20 times 100 is going to be 55%. You could also find that 55% because we know that this column, the percentage column, has to add to 100. So you can just do 100 minus 25 minus 20, and we're left with that 55%. So you could get it that way as well. How many schools are categorized as independent? So we look at independent, how many? So just make sure you realize what it's asking. So it's asking for how many. So it's 5. How many schools are there in total? So we're counting them. There is 20. But question D is asking for a percentage. So you got to make sure you're reading a question correctly. Is it asking me for a number, or is it asking for a percentage? So what percentage of schools are categorized as government? So we worked that out before. It was 55%. Now in question E, I know I'm going quite quickly, so you can pause me at any time, or you can listen to me on 1.5 speed if you like. Use the information in the frequency table to complete the following report describing the distribution of school type for these schools. Now, when we're going to do some of these questions, we are going to look at reports because there's no point in just looking, displaying the statistics or displaying the data without actually understanding what it's telling us. So we can see that more students go to government schools in this, sample of 20 people. So we've got 11 students at government, 5 at independent, 4 at Catholic. Or we could say that as a percentage. So if we were looking at maybe comparing school types, say in Victoria, to school types in New South Wales, then we would calculate the percentage. All right, so it's better always to calculate the percentage. All right, so let's have a look at the report. So we're just basically filling in the blanks. So something schools were classified according to school type. So that's how many schools there are. So 20 schools. Now usually when we start a sentence we write the word, but you could, if you wrote 20, it would not be wrong. So 20 schools are classified according to school type. The majority of these schools, all right, so we want the majority, and you can see it's being reported as a percentage, which is 55%. We're found to be, so what is that? Government. I'm just going to write gov. Of the remaining schools, something were something, while 20% were something. All right, so let's do this 20% first. So 20% were Catholic. So that means we're only left with independent. So 25% were independent. All right, so just filling in the blanks. So having a report there is really good for your SACs because you're going to have to actually summarize what is happening in the data. All right, just realized my charger came out. Moving along. Oh, just plugged my charger in. The table shows the frequency distribution of the eye color of 11 preschool children. Use the information to write a brief report describing the frequency distribution of eye color. So here we've got the percentages, so it's always better to refer to the percentages. All right, so how many, what are we doing? Preschool children. So 11 preschool children. Children were surveyed on eye color, on their eye color. You can say the same thing many ways. I'm just kind of going with whatever is coming to my mind. The majority, majority, which was brown. The majority, which is 54%, had brown eyes. 27.3, oops, I should put 0.5% in there, sorry guys. 27.3% had blue eyes. And 18.2% had hazel eyes. All right, so you can write anything that is similar to that. It's probably a good idea to highlight what the majority is, because remember that is also our mode. So the most popular eye color was brown. All right, moving along. Now let's have a look at some histograms. I really thought I was going to do this as a segmented bar chart. I was wondering why I put this under segmented bar chart. We didn't have to do segmented bar charts for this question, but I wanted to do it as a segmented bar chart. Sorry, that's why I put that in my heading. All right, so let's draw this one as a percentage segmented bar chart. So before we do, I'm going to compare it to a normal bar chart. So a normal bar chart will have, what categories do we have? We had 3, didn't we? So we had, I'll do it in order. So Catholic, government, independent. Catholic, government, independent. Now, if we're just doing the number of them, so you could do it as a percentage or you can do it as a number. So let's go 2, 4, 6, 8, 10, 12. So Catholic was 4, 11. So 4, 11, and then 5. Now, if we were doing percentages, we would have to create another graph. So let's just do that maybe we'll do that one in pink. So we still have the 3. So we've got Catholic, government, independent, and your top would go up to 100%. So halfway is 50%, 75, 25. We're just going to make sure we notice that it's percentage on that side. All right, so Catholic was 20, so it's going to go something like that. Government was 55%, so it's going to go up there. And then independent was 25%. Oops. All right, so the reason it looks a little bit lower is because this is just your frequency going up to 11 is your highest. This one here, we did as a percentage. So the difference between your highest value and the 100% is a little bit different. Now, when we're doing a segmented bar chart, we're effectively taking these bars and putting them on top of each other. So we know we have 11 in total. So if I color this one in yellow, I'm going to do it the same here so I can do it at the same time. Let's do this one in pink. No, that was 20, sorry. It's 20. I really need to stop doing these videos late at night. And that's blue. Pink. So instead of having the 3 separate bars, you just have one big bar. All right, so we're still going to have our scale here. Let's just do it like this. So our yellow, remember, is going up to 4, so it's going to go up to about there. Then for government, that was 11. So we're going to add 11 onto here. So 11 plus 4 is 15. And then remember, independent is 5, so it's there. So when we're sketching it, there's that pink section. Here's your yellow section. And then our blue section on, oops, excuse me, press blue. All right, and then our blue section. All right, so that's, you got a bar chart here. So this is your bar chart. This is your segmented bar chart. All right, it just means you've got one bar and you've got the sections in each one. And you would have a key on the side as well. So a key for each color. So we had government, independent, Catholic, I don't think it was in that order. And then the color associated with that. So your independent was that one. Probably should have it in order. There's your government and then Catholic down the bottom. Okay. Now, if you've got a percentaged one, percentage segmented bar chart, it's exactly the same thing. But this time we're going up to 100. So it's always obvious. Well, it also says percentage on it, but it'll go up to 100%. So your bar goes all the way. So kind of think of it as a pie chart, right? So a pie chart we do as out of 100, but it's not a circular pie, it's a square pie kind of, or a bar. All right, so we've got 50, just quickly do the scale. All right, so Catholic was at 20, then government was at 55, so we add on 20 to 55, and then we've got 25 left for independent. So there's your Catholic, there's your government, and then your independent on top. All right, so that's what a segmented bar chart is. So you got your bar chart up the top and then your segmented bar charts. All right, so it's basically building your bars on top of each other. All right, I'm going to skip now to histograms. So the number of chocolate chips per biscuit in a sample 40 biscuits was found to be as follows. I think there's a few spelling grammar errors in that question. All right, so we've got all our numbers there. There's 40 of them, which is very annoying. All right, so we're going to construct a frequency table for the data, including both the frequency and percentage frequency. What percentage, blah, blah, blah. What is the mode? Now, you can do this in a table and do a tally as you go along, but I'm going to show you how to do it on your calculator. So let's just clear what we had in there. All right, so we've got 2, 5, 4, 4, 5, 4, 6, 4, 4, 4, 5, 4, 4, 5, 6, 6, 5, 5, 4, 6, 4, 5, 5, 4, 5, 4, 6, 4, 6, 4, 5, 4, 5, 4, 6, 5, 5, 6, 4, 6. I'm bound to may have made an error there, but anyway. Now, it's hard to count them like that. So you can order your data if you wanted to. So we just go here and you can just go A to Z. And how many lists? Just one list, list 1. Right, and it'll put it in order for you. So you can see, probably count there how many are each one. And if you needed to put in order, you can. All right, I was just playing around to see if we could do a frequency table on here, but we can't. Well, I couldn't figure out how. So we can just have a look here. So writing our frequency table. So we've got number of choc chips. So number of choc chips. And then we'll do the frequency. And then we'll do the percentage frequency. Only 2 choc chips. It's a bit sad, isn't it? 2, oh, I'm thinking now I could probably do it as a histogram. So I'm just trying to think as I go. You can count them quite easily. So once you put it in order, so there's your ordering there, but I also noticed you can do sort here, ascending, descending. So when I was trying to find the frequency table, found it there. All right, so we've got one where we've got 2 choc chips. All right, so for 4, we go all the way to 17, but we started at 2. So that means we're going to only have 16. And then we've got the 5s. All right, so we're going from 18 to 30. All right, when I was playing around before, I actually deleted a 4, I just realized that. And when I was filling this in, I didn't put 0 for 3. So let's just fix those 2 things up. So there should be 17 for 4. Oh my gosh. All right, probably should stop after this video because I'm getting a bit tired. All right, so the total was 40. Now, I'll just show you what I meant by the histogram. So I haven't tried this yet, but I think it will work. So yeah, I was playing around with all different things before. So histogram. And then we want it to start at, we can start at 0, doesn't matter. And we'll just go up by 1. And then that should draw it for us. So here we've got the different ones. Yeah. So analysis trace. So we can see for 2, there's 1. And then for 3 is 0. So your frequency is here. All right, then for 4 we got 17 and so on. So you could have counted them that way, but I think it was, yeah, not that difficult to count them once they were in order as well. All right, so to calculate the percentage, we just go 1 over 40 times 100. All right, sorry, just doing that on the calculator. Don't worry about that, I was playing around with some percentages before, but it's probably just easier to do it on the main screen. So we go shift, divide to get our fraction up. So 1 over 40 times 100. So we have 2.5%. Obviously 0 is going to be 0%. Then 17, so we can just do the same thing. We can highlight and drag it down. So we change that to a 17, so 42.5%. Then we've got 13. So again, we can drag it down. 32.5. And then lastly, 9%. 22.5%. And if we added them all up, we will get 100%. All right, so there's our frequency table. We've got the frequency and the percentage. What percentage of biscuits contained 3 or less chips? So here's 3 or less. So it's just 2.5%, so not too many. What is the mode of this distribution? So the most popular. So most biscuits had 4 choc chips. So there must be pretty big choc chips, or I'd be disappointed if they were the small little choc chips. All right, let's have a look at the next question. So the number of children in the families of 25 VCE students are listed below. Use a CAS calculator to construct a histogram so that the column width, blah, blah, blah. What is the starting point? Okay, so we can do all that in a sec. I'm just having a quick look. We'll do this question because it's on the sheet, but histograms, I probably should have just done with the data that I already put in. So go statistics, clear what we've got in there. All right, quickly enter the data. All right, so just make sure we've got 25. They all look pretty good. If I was doing this on a SAC, I would definitely take my time to check that I've entered it correctly. All right, so we want to do a histogram. So any chart we want to do on the calculator after entering the values, we just press this button up here. All right, and we're not doing a scatter plot, we're going to do a histogram. And we entered our values in list 1, so we just put that there. And you're like, oh my God, where's my histogram? You just press this button here. We'll draw it. So this window here, we just have to set the conditions for the histogram. So we're going to have a width of 1, and we're going to start at 0.5. So we're starting at 0.5, and we're having a width of 1. So H start, just the histogram start, and H step is your width. All right, so there's our histogram. So that helps us, like I was saying before, that's basically a box plot that's just close together because you've got data here that you don't really have a range for. What is the starting point of the 4th column? So we can just go to analysis, trace, and you get your little cursor. So we just go across to the 4th column. So 1, 2, 3, 4. So that your starting point is here, so 3.5. So that this column here goes from 3.5 to 4.5. And the count is here, which is 5. So basically that means the number 4 has occurred 5 times. All right, so we can treat this like we did before to help us count our frequencies. All right, redraw the histogram so that the column width is 2 and the first column starts at 0. So we can just go back to our table, go back to here, and we can start it at 0, and we want a column width of 2. So we can see we've got fewer bars this time. What is the count in the interval from 6 to less than 8? So we go analysis, trace, we want to go up. So I want to go until I see 6 here. So go across and gone too far. There it is, 6. So the count is 2. What actual data values does this interval include? So we have a look back at our raw data and what is between 6 and 8. So we've got 6 and we've got 7. So there's our 2 values. All right, so what is the count? It was 2. What actual values? It was 6 and 7. If you're drawing a histogram, just make sure that for a bar, you have a number here. So let's say that was 1. Let's call it 0 and 10. And then your next one would be 20. So they have to be the same width, but your numbers go at the end. It's a little bit harder to see on a calculator because it's got the scale there. It doesn't actually put them at the ends all the time. It has numbers at the end, but they also have numbers in the middle, which can sometimes be a little bit confusing. All right, determining shape, center, and spread from a histogram. So for this one, we're going to look at each histogram and look for the mode, which is also called the modal category or the modal interval, any potential outliers, and the approximate location of the center. All right, so we're going to following histograms and mark the following. All right, so we're going to also call it symmetrical, positively skewed, or negatively skewed. So let's do the shape first. So that's whether it's symmetrical, negatively skewed, or positively skewed. So just going back to your notes, remember, you've got it written in your notes. There's symmetrical here, and then we've got positively skewed, and there's negatively skewed. All right, an outlier is something that is very on the end. And what was the other thing we had to do? The mode is the peak. Where is your peak? And the approximate location of the center. So we could go through the frequency and work that out as well. All right, so let's do the shape first. So this first one is it's clearly got an outlier. So there's an outlier. And it's tailing off in the positive direction, so it's positively skewed. All right. Now the mode is here. All right, we can't actually, oh, there's no scale. So there's your mode, it's your highest one. And the approximate location of the center, it's probably around here as well. All right, so you're maybe, no, not there, maybe more on this side. So your center's probably around there. All right, it's a bit harder to do without a scale. Oh no, it's not. What am I doing? We've got a scale here, we've got a frequency there, but I would say the center's around there. I'm just conscious of time and how long this video is going for. So your center would be around there. All right, so for the next one, it's like, oh, I wouldn't even call that symmetrical. It's definitely not skewed. We could probably call it symmetrical if we had to choose one. Do we have an option not to have any? All right, symmetrical, approximately symmetric. All right, then what else do we have to do? There's no outliers. The mode, this one is just higher, so this one is your mode. There's no outliers, and the approximate location of the center. When it's symmetrical, it's in the middle. All right, so there's your center. All right, for C, now you're probably thinking it doesn't really look symmetrical, so it doesn't have to look symmetrical. So often any real life data wouldn't be symmetrical. It's probably impossible to have it symmetrical, so that's why it's called approximately symmetrical. So this one here, you've got your peak in the middle, and yeah, either side it kind of goes down like that. So it's symmetrical. There's no outliers. Your center would also be in that middle there. And is that all we had to do? What was the other thing? And the mode is there in the middle. All right, so for D, there's no outliers. The distribution is positively skewed. All right, your mode is here. All right, so the highest column. And then your center is probably somewhere around here. All right, if we had to work it out, you would see it's probably somewhere around there. I'm just kind of approximating its location. All right, so for E, I can see it's skewed and it's going in the negative direction, so it's negatively skewed. All right, no outliers. Your highest point is here. There's your mode, and your center is probably going to be around here somewhere. All right, so for the next one, it does look symmetrical because it's going down like that. And that's where we've got the double peaks. All right, so double peaked, symmetrical. All right, now your mode, oh, looks like it's going to be this one here. And because it's symmetrical, your mean or your center is going to be in the middle again. So there's your center approximately. All right, so when you're looking at exam questions, often you're asked for the shape. So that's whether it's symmetrical or positively skewed or negatively skewed. So just make sure you're so used to looking at histograms that you can tell straight away, but also remember you've got it in your bound book. So make sure you use your bound reference. All right, then we're moving on to box plot. So we'll end this video here. All right, bye guys.